Hello friends, welcome to the today's session. In today's session, we'll be discussing some of the important multiple choice questions based on the topic from thermodynamics. That is, in today's lecture, we'll be covering the multiple choice questions based on the topics zeroth law of thermodynamics, first law of thermodynamics, equation of state and work done during an adiabatic and isothermal process. So let us start with the today's session with the first multiple choice question. The first multiple choice question is internal energy of real gas depends upon option number 1 is temperature of the gas, option 2 only on the volume of the gas, option C only on the pressure of the gas, option D both temperature and volume of the gas. All of us know that internal energy is nothing but it is a function of temperature. But from first law of thermodynamics, if I write the expression for the first law of thermodynamics, this can be written as dq is equal to du plus p into delta v. In this term, in this equation, the first term dq, that is called as amount of heat, du is called as the second term du is called as internal energy, and the third term, that is product of pressure into volume, that is called as the work done. So this quantity which is there du, this is called as the internal energy. Now if I rearrange this equation for the internal energy, from this one we can find out dq minus pdv, means the internal energy depends upon the amount of heat given to the system and the work pressure volume type of work done. So from this equation, as we know that internal energy is a function of temperature. So first option is also correct, and internal energy depends upon the pressure volume type of work done. So it is the option D which suggests that it is the both temperature and the volume of the gas. So the correct answer for this question is option number D, both temperature and volume of the gas. Now next question is, what is the change in internal energy per gram of air if 12 gram of air is heated from 0 degrees Celsius to 5 degrees Celsius at constant volume by adding 120 calories of heat? Okay, so the options are given over here: 10 kilocalorie per gram, 50 calorie per gram, 10 kilocalorie per gram, 50 kilocalorie per gram. So actually this is the problem based on the first law of thermodynamics. First of all, we will try to note down the problem. See what it is given. It is given that the change in internal energy we have to calculate. What is the change in internal energy per gram? Means energy is measured in terms of calories, or joule it will be measured per gram, means we have to calculate answer in terms of calories per gram. We have to calculate the answer is in terms of calories per gram. If 12 gram of air, means amount of substance it is given, that is 12 gram, and this temperature is increased from 0 degrees Celsius to 5 degrees Celsius, and the most important thing is that this process has been carried out at a constant volume. As the air is heated at a constant volume, so the change in volume it will be 0. So I had written dV is equal to 0 in this one, and the amount of heat given to the system, that is 120 calories. Amount of heat given to the system is 120 calories. If I write down the first law of thermodynamics, it will be dq is equal to du plus p into delta v. Now as 120 calories amount of heat it is given, so let us say dq is the amount of heat given through the system. If I substitute the value of dV is equal to 0 in this expression, dV is equal to 0, if I substitute in this equation, so what I'll get dq is equal to du. I'll get an expression dq is equal to du. Now it is a 12 gram of air and it has been given amount of heat, it is 120 calories. So 120 amount of calories amount of heat it is given, and from first law of thermodynamics we got dq is equal to du. So dq is equal to du is equal to 120 calories. Now what we have to calculate is the internal energy per gram. Internal energy per gram we have to calculate. So internal energy is represented by du, okay, and amount of substance, it is this amount of heat it is given for a 12 gram of the substance. It is for the 12 gram of the substance amount of heat it is given. So I have to calculate for the 1 gram. So I have to divide this amount of heat by the 12 gram of the substance. So du is nothing but the dq. So I had substituted the value of instead of du I have written dq and this 12 as it is. Now if I further simplify this, I know that amount of heat given it is 120 calories and the amount of substance is 12 gram. So if I do this simple division, then it will be coming out to be 10 calories per gram. So if you look at the options, then it is option A which is the correct answer in this question. Okay, so answer A, option number A is the answer. Now next question is, out of the following, the physical quantity that relates with the first law of thermodynamics is, the options are given over here. First one is the temperature, the second one is the pressure, third one is the energy, and the fourth one is the number of moles. Now we have to find out the physical quantity that relates with the first law of thermodynamics. We know the first law of thermodynamics is nothing but dq is equal to du plus pdv, means amount of heat given to the system, that is dq. How it is utilized in a given system, the first purpose is to increase its internal energy and the second purpose is to perform some amount of external work done. So sometimes this first law of thermodynamics, it is nothing but it is an extension of law of conservation of energy. So if I say that from that point of view, this first law of thermodynamics is related with the energy of the system. So correct answer in this case is the option number C. Next question is, zeroth law of thermodynamics is kinetic energy of molecule of gas is 0. Option B, ideal gas does not contain molecules. Option C, if two systems are separated in thermal equilibrium with a third system, then they themselves are in thermal equilibrium with each other. And the option D, absolute zero temperature cannot be attained. In our earlier theory lecture, we had discussed what is zeroth law of thermodynamics. Zeroth law of thermodynamics says that if there are three bodies, A, B and C, if A body is in thermal equilibrium with the B and third body is there, let us say that is C body C, it is in thermal equilibrium with the first body, that is A, means B is in thermal equilibrium with A is in thermal equilibrium with C, then from zeroth law of thermodynamics we can say that this second body and the third body, those two bodies will be in a thermal equilibrium. So it is the option C, it is the correct answer in this case. If two systems are separated in thermal equilibrium with the third system, they themselves are in thermal equilibrium with each other. Option C is the correct answer in this case. Okay. Now next question is, the equation of state for an adiabatic process is option A, PV is equal to RT, option B, PV raised to gamma is equal to constant, option C, PT raised to gamma is equal to constant, option D, none of these. So all of us know that for an adiabatic process, the relation between the pressure and volume is nothing but the PV raised to gamma is equal to constant. So in this, correct answer for this question is option number B, PV raised to gamma is equal to constant. Now next question is, the internal energy for an ideal gas undergoing an isothermal process will be, options are given over here, increase, decrease, zero, none of this. All of us know that internal energy is a function of temperature, and for a isothermal process, temperature of the system remains constant. But we know that as the internal energy is a function of temperature, as T is constant, so change in internal energy will be zero. So there will be no change in the internal energy as the temperature of the system is constant, as the system is isothermal system. Okay. system is following a isothermal process, so temperature is constant, there will be no change in internal energy, means in this case the correct answer for this question is option number C. So option C, 0 will be the internal energy for an isothermal process. Next question number 7 is the area enclosed by an indicator diagram represents option A, work done, option B, internal energy, option C, pressure, option D, entropy. We know that indicator diagram for an or PV diagram for any case, it represents the relation between a pressure and volume. So if you have any system, it may follow, let us say this is the path followed by this system. Let us say its volume is increasing from V1 to V2, pressure is decreasing from P1 to P2, or whatever may be the parameters. We have just considered a general example. We know that if I want to calculate the area under this curve, means if I want to calculate the area under this curve, if the system is increasing its volume for V1 to V2, then area under the curve is nothing but the product of the Cartesian coordinate on x-axis and the y-axis, which is on x-axis it is volume and on y-axis it is pressure. So it will be the product of pressure and volume. So if I further simplify this, I know that I can rewrite this pressure in terms of force upon area. We'll be just going in a dimension analysis way, and volume we can rewrite as a distance into the area. Okay, so if I cancel this area with this area, so I can get area under the curve is nothing but the force into the distance. I know that force and distance, force into distance, it nothing but the, it is a dimension of the work done. Okay, so if you see force into work, force into distance, it is nothing but it is coming out to be the work done. So in this case, the correct answer for this question, it is work done. So option number A is the correct answer. Question number 8, the work done in isothermal expansion will be, first option, second option, third option and fourth option are given over here. This way all of us know that the work done during an isothermal process, it is given by the formula W is equal to nRT, natural logarithm of final volume to the initial volume. Okay, and so in this case the correct answer for this question is the option number A. But sometimes it may happen in the exam, this straightforward question will not be asked. Instead of this natural logarithm, some people may give logarithm with respect to the base 10. In that case, you have to multiply by a conversion factor of 2.303. In that case, the work done in an isothermal process, it will be W is equal to 2.303 nRT log V2 by V1, and that log will be with respect to the base 10. So, and sometimes it may also happen, as in this case it is a expansion. So if the expansion will be there, then final volume it will be greater than the initial volume. So in that case work done will be positive, and if it is a compression, then the final volume it will be lesser than the initial volume. In that case the work done will be negative. So it might happen sometimes in the exam that instead of asking the formula, they may ask you the question in the fashion that work done during an isothermal process will be positive, negative, 0 or infinity. So in that case you have to remember that if it is an isothermal expansion, then the work done during that process it will be positive, and if the work done during an compression it will be asked, then you have to remember that work done during an compression it will be negative. So in this case the correct answer for this question, it is option number A. In order to further go into the details of this question, you can watch the lecture from our channel Basics of Physics from the playlist Heat and Thermodynamics, whose link I had given in the this one. This is the link. You can directly go into the channel and in the playlist Heat and Thermodynamics. You can search the lecture by the title work done during an isothermal process. So in this case the correct answer for this question is option number A, nRT log V2 by V1 with respect to natural logarithm. Next question is the work done when a 1 mole of a gas expands isothermally at 27 degrees Celsius to double its original volume is. Options are given over here. So first of all, we will find out what is the given data. As the work done we have to calculate. So W is equal to question mark. W is equal to question mark. 1 mole of the gas is given, so N is equal to 1, and the temperature of the system it has been given, which is 27 degrees Celsius. So T is equal to 27 degrees Celsius. Degree Celsius we will convert it into the degree Kelvin. Just we have to add the 273 to that one, so it will be 300 degree Kelvin. And also it has been given that to double its original volume, means the final volume it will be twice of the initial volume. So it is V2 is equal to twice of V1. So work done during an isothermal process, we know the formula that nRT log V2 by V1. So for the calculation purpose we will be using a calculator, so we can use the log to the base 10. So its formula it will be 2.303 nRT log V2 by V1. Now we'll just substitute the value 2.303 as it is. Value of N will be 1, we had not written that one. Value of R it will be 8.314. Temperature of the system it is given over here, which is 300 Kelvin, and log V2, in this case V2 is equal to twice of V1, so we had written it is twice of V1 and this V1 as it is. Okay, so V1 will get cancelled. So what you will get, 2.303 into 8, it will be come out to be 19.1471. This 300 added as it is. V1 will get cancelled, so here in this case you will get only log of 2. Now if you do this simple multiplication of these first two terms, it will come out to be 5744.1426, and log of 2, if you look into the log table, its value will come out to be 0.3010, and if you do this simple multiplication, the answer will come out to be 1729 joule. So if you look into the options, then it is the option B which is the correct. So answer for this question is option number B, 1729 joule. Next question is, when a gas expands adiabatically, work done per mole will be option A, R P1 minus P2 upon T, option B, R T1 minus T2 upon gamma minus 1, option C, R V1 minus V2 upon gamma minus 1, option D, R in bracket P1 minus P2 upon gamma minus 1. This we have already discussed in our theory lecture, whose link I had given you over here. You can directly search into our YouTube channel Basics of Physics in the playlist Heat and Thermodynamics. You can see this lecture by searching work done during an isothermal process. You will get the derivation of this work done. So in this case the work done it is coming out to be R T1 minus T2 upon gamma minus 1. So in this case the option A is the correct answer. Now the next question is, in the two gases at the same temperature, the average kinetic energy per molecule is equal, internal energy is equal, entropy is equal, none of this. We know that internal energy is a function of the temperature. Okay, so that if the temperature will be equal, then the internal energies of the two systems will be equal. So in this case the correct answer is option number B. Now next question is, slope of adiabatic curve through a point in PV diagram is dash dash times the slope of isothermal curve through the same point. Means we have to calculate the slope of adiabatic curve and isothermal curve. Slope of adiabatic curve and isothermal curve on a PV curve. On a PV curve we have to find out. So the options are given here. Option A, pressure, option B, volume, option C, temperature, and option D, gamma. All of us know that for an isothermal process, the relation is PV is equal to constant. If I differentiate this equation, I have to use the product tool. So I'll use first constant into derivative of second, that is P constant into derivative of second, it will be dV, plus second constant, in this case V will be constant, and derivative of first it will be dP, is equal to derivative of constant term, it will be 0. So if I rearrange this equation, if I transfer this P dV from this side to this side, it will be minus, because on this it is plus. So V dP we are getting is equal to minus P dV. So if I want to calculate the slope, then it will be dP by dV is equal to minus P by V. It will be minus P by V. Let us call this as an equation number 1. Let us call this as an equation number 1. Now similarly we will calculate the same for the adiabatic curve. Now for adiabatic process, we know the adiabatic relation is PV raised to gamma is equal to constant. If I differentiate this equation, I will get P constant into derivative of V raised to gamma. It will be V raised to gamma is a power function, so we have to multiply the power, that is gamma, it will be multiplied, and we have to decrease the power by 1, so it will be V raised to gamma minus 1 into derivative of V, it will be dV, plus now second constant, that is V raised to gamma as it is, and derivative of first it will be dP is equal to derivative of constant, it will be 0. So second term it will be like this. Now what we will do, we will transfer the first term on the right hand side. So it will be minus P into gamma V raised to gamma minus 1 into dV. Now I need to find out that value of dP by dV. If I transfer this V raised to gamma from this side to this side, it will get divided. So it is P into gamma into V raised to gamma minus 1 divided by V raised to gamma. Now this V raised to gamma minus 1, this V raised to gamma, they will cancel each other. I just have to transfer this to the numerator. So we know the simple laws of the indices. If a raised to m it will be there upon a raised to n will be there, then resultant will be a raised to m minus n. So this gamma it will become minus in this expression. So it is gamma minus 1 minus gamma. So this gamma will cancel with this gamma. So here you will get minus P into gamma V raised to minus 1. So if I further transfer this V raised to minus 1 to the numerator denominator, it will be P by V. So dP by dV for an adiabatic process will get minus gamma into P by V. Let us call this as an equation number 1. Let us call this as an equation number 1. If I substitute the value of minus P into minus P by V from equation 1, which is dP by dV for an isothermal process. So from this equation I can rewrite dP by dV for an adiabatic process, dP by dV for an adiabatic process is equal to gamma times dP by dV for an isothermal process. So in this case the correct answer is the slope of adiabatic curve through a point in a PV diagram is gamma times the slope of isothermal curve. So the correct answer for this question is gamma. So that is nothing but the option number D. That's it for the today's session. I thank you all the viewers for attending our sessions, and I request all of you to please share our videos for all the students who are preparing for the various competitive exams and the online examinations. Thank you. We'll stop here for the today's lecture.